Go. Okay, so a function. You have learned that a function has to pass a vertical line test. But if I told you just this, y is equal to x cubed plus 4x, there's a way of telling without graphing it that it's a function. Without graphing it. And it's really simple. If you can solve it for y, which this one already is, and you only get one rule, one equation, then it's a function. That's a function. Because why? Because there's only one y equals. If I solved it for x, do you get that I'd actually get 3 answers? Think back to this. You remember how if we solve for x, you're going to get however many the exponent is? There'd be 3 answers for this one. All right. Now I know if you wanted to just graph it, you could say, oh, here's what it looks like, and it passes the vertical line test, so it's a function. That's the way it still works, but you have to know how to do it when you can't graph it. All right, so let's give you another one, a counter example. This one that I'm about to write is not a function. Y squared equals blah, blah, blah. You know why? Because if I solve it, it'll have more than one equation. What do I mean? Well, watch. Square root, and I do the square root of y squared is, if you think it's y, then you would think there's just one answer to this. But hopefully by now I've beaten it through to you that this is the absolute value of y. Then you'd understand that, oh, so there's actually, I got to break it out of the absolute value. There's 2 answers for this. All right, let me go back to that for just a second. See, the problem stems from this. People go like this, and they get taught when they were younger that that's x and that's plus and minus 4. But then they think that the square root of 16 is 2 things. It's not. And they think that the square root of x squared is just 1 thing, and it's not. So that's the sloppy, quick way to teach this. I'll admit it. A long time ago, I used to teach it that way too. I didn't know it was so important. Okay, so now I know we got to teach it this way because people need to understand that the square root of x squared is 2 things. Especially matters right now when you're solving this. You need to know that the square root of y squared will be 2 things. The absolute value of y will be 1 thing, x to the 3rd plus 4x. But then you have to get it out of the absolute values, you got to break it up into 2 equations. It'll be y equals square root of x to the 3rd plus 4x, and y equals negative, which is a reflection of the other one, square root of x to the 3rd plus 4x. Do you get if you graph 2 things and one's a reflection of the other, it's very likely it won't pass a vertical line test then? All right, so the rule is if something's going to be a function, then you have to be able to solve it for y and have only one answer, one rule, one equation. Okay? All right, one more thing you have to be able to handle is, let's say I give you 3 points, 2 comma 6, 1 comma 6, and 3 comma 5. You can tell just by looking at those points whether or not that little family is a function or not. Do you remember the deal where like each input has to have only one output, and it's confusing. Even for me, I forget which ones are like okay. Like let's say there's that one compared to this one, which is 2 comma 3, 2 comma 5, and 7 comma 1. Which family is a function? And which family can't make it into the function club, but they are at least a, what's the other thing called? A relation. So which of these 2 families is a function, do you think? The black one or the red one? All right. I heard a bunch of people say black. The black family here, the family of points, those are a function, and here's the easiest way to check it. Do you get if I graph to those 3 points, they still have to pass the vertical line test? You don't have to think through that whole like if the input is the output is the, that can be really confusing. This way it would work. You would just have to graph these 3 points. And would any of them line up on top of each other? Well, I'm going to graph them quick. Over 2 up 6, just roughly. Over 1 up 6. Over 3 up 5. Did any of those appear to fail the vertical line test? No. Whereas if I graph this one, the red family of points, I go over 2 up 3, over 2 and up 5. Oopsie. See what I mean? Those 2 lined up right on top of each other, therefore fails the vertical line test. Okay? So, two of our ways of telling if things are functions really can boil down to the vertical line test. The one other way is if you have something like this. You don't know what that looks like. I have no idea what that looks like. If I could graph it, I could see if it passed the vertical line test, but I can't graph it, and I don't know what it looks like. But you can tell me. Is it a function or not?
It is not.
It is not a function. Because it would not have just one what? One solution or one rule. All right. One more thing I got to teach you is, and just to clarify on that one, if I were to solve it, I would subtract this x and this x, get them on the one side. I would divide by -3, but at the end I'd have to take the third root of. It'd be y to the third equals something, and I'd have to take the third root of something. That's not going to have just... Actually, wait a minute. Oh, this is a really tricky one. The third root of something? You don't have to have the square root, and therefore this actually would only have one equation. Oh, that's nasty. It's true, though. Let me talk that through. So if it was y to the third, I don't think we'd do that to you on the test, but let me explain it quick. If you take the third root of -8, you can do it, can't you? And it only gives you one answer. And it's -2. So this kind doesn't need the absolute values in it because it can handle negatives. Third roots, there is only one answer. So there's actually only one equation. So really we should refine this even further. We're not likely to do anything other than squared. But if we did, y squareds, those always have two answers. Let's say it was y squared equals 144. You go square root, and you got to have an absolute value comes out of these. But if it's third root, or fifth root, or ninth root, any odd root, you wouldn't have that problem. So bottom line, watch out for even y's, even powered y's, because those won't be functions, because those will have more than one answer. Okay, I got to do this quick, unfortunately, because we have a lot to cover today. So one last thing. If I gave you this picture and said, what's its domain? Can you tell domain-wise, domain goes like this, that it goes in both directions forever, and therefore the domain is all reals, also known as negative infinity to positive infinity? All right, let's say, though, that the lowest spot it goes here is at 3. So that right there is at 3. Then can you write the range for me of that function? Did you say from 3 to infinity? Then you remember range. If you don't remember range, I'm going to do one more, and I'm going to hope you can catch on. Range is this way. It's how far does it go this way and this way. Okay, let's do one more. Everybody hates this one, but it is probably one of the more complicated pre-calc level domain and range questions. Do you remember the graph y equals 1 over x? What's its domain and range? The domain on this guy is, does it go forever in both directions? It goes forever this way, and it goes forever that way, but there's something it can't be when it comes to x. Yeah, x can't be 0. Very good. So therefore, I have to say it goes from negative infinity up until 0, but then it stops working at 0. Union with, it starts working again just after 0 and goes to infinity. All right. And how about the range? I'm going to take a second, have you think through the range. It's similar. See if you can get what the range is for this guy. Well, range is this way. And it definitely goes down to negative infinity. But it doesn't go forever either. In fact, 0 it's the same exact thing. It can't be 0. Okay, there's a quick review of domain and range. Your homework is to just do one page. I'm going to pause for a second while I figure out how to describe that page. Okay, I'm going to describe it verbally. This is from day 1 of 2.1. So section 2.1, day 1. And in the homework, there's a page that's blue, and it starts with problem 15. And it's a little parabola there. And it asks you for the domain and range of it. That page, just that one page. I know there's lots more to the homework. We're not doing all of that because we're doing the top 20 today, and that's going to suck up the rest of our time. Okay, did you find it? If you're in class, you're seeing it up on the board here. It's kind of goes from yellowish to bluish gradient, and it starts with a 15 in the upper left-hand corner, and it's a parabola. And you find the domain and range. In the directions, if you look close, if it's not a function, which you should be able to tell, because we just talked about that, if it's not a function, you don't have to tell us domain and range. So if you realize, oh, this thing's not a function, don't agonize over what its domain and range would be. Okay? Because domain and range is, for non-functions, follow different rules. So at a minimum, we're not doing them. All right, any other last questions? Then, that's your homework for today, and that's all I got for the video for today. Next, we're taking top 20, and I want to really encourage you guys, if it turns out this goes badly for you, take the time to learn them now. It actually should have been a week ago, but you could still benefit a lot if you learn them now. You wait another month, you'll have cost yourself a whole bunch of problems wrong on the next few tests. Also, you can have unlimited retakes on it. Take me up on that. Come in and do it over again. Keep upside down because it is a timed test. Why would you give us a timed test? Well, because the ACT is a timed test. And if you have a way to do it, but it's really slow, then I suggest you let me teach you a faster way. And all of these can be done efficiently. I can tell already I'm going to run out of one in a second here. If I have any extras sitting around here. There. Yes. Have extras. You can keep them upside down when you're fastening them back. I appreciate that. Did anybody not get one? You want? No. All right. I don't blame you. You got one? Okay. On your mark, get set, go. Maybe we'll get something in the other room when we get back. 15 minutes in so far. 5 minutes, maybe 6 minutes.